In this video, we will talk about the TCP, and then we will continue the TCP concepts by talking about the control flow and connection management mechanism and TCP. So this is basically what is required at the receiver protocol stack. So at the bottom you see the network layer, the IP, and then this is the transport layer, TCP, that we are discussing. On top of it is the application process. So when some data is received from the sender, it is passed to the TCP socket here. This is basically a buffer, so that has some memory, right? There's a specific space here, and then it can accept some data. So when the data comes from down, then it is passed to this TCP socket. It is written here, and then the application process from the top just comes and reads this payload, and then reads the data and sends it to the application process. So the question here is that if the network is delivering some data, it puts it into this buffer, right? And then there is also some consumer, which is the process in the application process above. So what happens if the speed between these two is not does not match? So it means that the sender sends too many data, but then the application process is slow at consuming those data, and then reads those data and removes it from this buffer. So that's the question. So what happens if the network layer delivers data faster than the application layer removes data from the socket buffers? So this is basically what happens. It cannot consume it, and then it doesn't know, it is overflowed. So a specific mechanism that the receiver uses is that you remember the TCP segment, it had a receive window. So it is for flow control. It says the number of bytes that it is willing to accept, and then it sends it to the sender. So the sender knows what is the number of bytes that the receiver is willing to accept. And when this number is sent, basically it means that the sender cannot transmit too much data too fast. So it will match sending the data, and then how much data it can send by what is advertised by the receiver. So look at this buffer here. So this is the total space available. This is the receiver buffer at the TCP, like this is the TCP socket, right, on the receiver buffer. So this is the total data that is available, and then some of it is the buffered data, some of it is free. So this free one is the receiver window. This part, this number, this value is sent and advertised by the TCP receiver. So it says that, hey, this is how much free buffer I have, and then includes it in the TCP header, and then the sender basically knows that it should limit the amount of unacknowledged data to this receiver window, this free buffer space that you see here in gray. So how much the receiver buffer size is, this is usually set by the operating system automatically, and then the typical default is 4096 bytes. So just remember again that this is the receiver window, and then that's basically the free time, the free buffer that it says, hey, this is the number of bytes that I am willing to accept. So this is basically flow control. It is pretty easy. The next topic that we are going to talk about is the TCP connection management. So since chapter 2, we have discussed about the handshaking protocol, this connection oriented TCP. So now we want to see what does that connection oriented it actually mean. So basically it means that before exchanging the data, sender and receiver handshake. But what does it mean? So think about the implementation. What we are discussing is implemented in low level with programming languages, right? So basically it means that when they are handshaking, the sender and receiver are handshaking, the first thing is that they agree to establish a connection. It shows that both the client and server are alive, and also they are willing to accept this connection, so to establish this connection and then exchange some data. At the programming level, there are some specific parameters that should be set. What are those parameters? We have discussed about the acknowledgement number and the sequence number, both at the client and server side. So then these are basically some parameters, the sequence number, and then at both sides, both client to server and server to client. So there is a sequence number that should be sent. These are the variables, these are connection variables. Then the receiver buffer size, how much it can receive both at the sender and receiver, and some other variables that you have seen previously. So these are the variables that they send to each other when they are establishing this connection, so the other party knows that what is the initial sequence number from the client to server, and then what is the initial sequence number from server to client. So establishing a connection is like a handshake in humans analogy. So here Alice and Talk are talking to each other, and Alice and Bob are talking to each other. Alice says, hey, let's talk, and then Bob says, okay. So after that they start talking, right? So this is a connection establishment. Let's see if this two-way handshake is good for client and server. That's basically the same thing that is happening at the client and server. So the client chooses some number, which is the sequence number, initial sequence number that it wants to start, and then it requests a connection, and then the server sends then, hey, I have accepted this connection, and then replies back to the client. But the point is that we have a lot of variable delays here. We have discussed about these delays so many times. When the messages are transmitted, then the delays can occur both at this side, sending and receiving, like sending the actual message and then receiving the ACK for that. Then the messages, because of this, the messages can be retransmitted. So for example, double connection request can be sent to the server due to the message loss. For example, there is message reordering, and the main point is that they cannot actually see each other. So let's see what happens. So the question is the two-way handshake enough in client-server application in TCP? Basically in TCP protocol, is the two-way handshake secure enough, or like reliable enough? Secure not from the security side, but is it reliable enough to have the two-way handshake? So the first scenario is that the client chooses some sequence number that we call it X, then requests a connection and sends it to the server. The server accepts that connection. The connection is established. After that, the client sends the data. So remember that the sequence number was X, and then on this requesting a connection is basically one bit that is sending. So this is X plus 1. This is the sequence number for the data. Then the data is accepted at the server side, the acknowledgement is sent, and then the connection for this message transmission is completed. This is great. There is no problem. Everything was great. So this was actually the ideal case. In the second scenario, it's exactly the same thing. So the client chooses some X, sends it, then this connection is established, and at some point this connection is finished. But we have discussed about delays and transmissions and retransmissions, right? So this one, the acknowledgement, the acceptance of the connection is delayed. The receipt of this is delayed at the client side, so that the client retransmit the connection request and sends it to the server. And this is not something unusual. So this can happen based on what we have discussed so far a lot, because of the message loss and then the delays, etc. So then it means that at the server side, a server receives a connection request after the previous connection was was completed. So it establishes a connection and then sends an acceptance, but then the problem is that there is no actual client, so the connection is half open on the server side, and there is no recipient for this one. So let's see why this is a problematic way. So this is another scenario, and in this scenario we'll see why this is problematic. So this it's the same thing. So the client sends a request connection, the acceptance is sent, and then it sends the data, and the problem occurs here. So the client, similar to the previous scenario, it retransmits the request because the acceptance was delayed, the receipt of the acceptance was delayed. So after this established connection happens after the client server, the client terminates this connection, and then the server accepts that connection, establishes a new connection. And again, this is not out of thinking, so this can happen, that again the acceptance of this data, the acknowledgement of this data is delayed. So then the client retransmits the data again. This is considered as a new establishment on the server side. So then the server accepts that data. And now think about that. That data is basically a message including to withdraw $100, for example, or something like that from your bank account. So you don't actually want that, right? This is a duplicate message. And this duplicate message is accepted at the server, and then this is the problem. This is not what meant on the client side. So because of these problems, the TCP has actually a three-way handshake, and that three-way handshake works like this. So the client has a socket, then it sends it chooses some initial sequence number that we call it X. So remember those scenarios that it was sequence number 92 and then it sent some data. That 92 is some initialization for this sequence number that the client chooses. So it doesn't always start at 1. It is some random number that it chooses, right? And then the client also sends a TCP SYN message. The SYN message is basically just a 1-bit message. In a TCP header, just take a look at the TCP segment structure slide again. So there were 3 bits that were used for connection management. So the SYN message is basically a SYN bit that is turned on. So the SYN bit is equal to 1, and then it also sends a sequence number. At the server side, it's also listening. It receives the SYN bit, the SYN message. So it also wants to tell the client, what is my sequence number? What is the start of the sequence numbers that I am going to send you? So it chooses some initial sequence number Y, and then again, this is the establishment, so it has a SYN bit 1, but it also has to acknowledge what it has received previously. So what it has received previously was an acknowledgement of the SYN ACK. So the TCP SYN ACK message is sent, and because this is an acknowledgement, also this acknowledgement number is 1. So this is basically combined into 1. So just review it again. The SYN bit is set to 1, and then the initial sequence number by the client is sent to the server. That's X that it was chosen. Then the server has to send an acknowledgement. So what is that acknowledgement number? X plus 1, right? X plus 1 is sent. This is an acknowledgement message. So there is an ACK bit that is set to 1 in the TCP structure, and it combines also other things. So it says, hey, this is a sequence number that I'm choosing as the initial sequence number. Let's call it Y, and then on this side also, this is still a SYN message, the SYN message that is combined with the SYN ACK, and it's set to 1, and it's sent to the client. So this is what we had previously, but then here this client also, after it receives it, it sends another acknowledgement for what it has received. What it has received is this sequence Y and then the SYN bit, right? this is an acknowledgement of what it has received from the server side. So it says the acknowledgement number y+1 and then sets the ACK to 1, and it sends the acknowledgement what it has received to the server, and then after this point then the client and server start we say that they establish a connection. So this is a three-way handshake, 1 2 3, three-way handshake. After this point it shows that, hey, there's also the client is also alive, and the acknowledgement of the message that it was sent is received at the server side also. And the point is that some of the actual data, the payload data that we are discussing that should come from the application layer, can also be combined into this last message that is sent from the client side to the server side. So this is pretty much how the TCP connection management is. But then when they want also to close the TCP connection, they send some message to each other by setting the fin bit to 1, and then they respond to this received message also with some acknowledgement, and they can also handle it simultaneously. So we have discussed all the principles for the reliable data transfer and how the connection-oriented transport TCP works. There are still some specific and very important concepts that are left at the TCP, and the main point is that how it controls the congestion. So first we will discuss some principles of congestion control, and then we will see how TCP is controlling congestion and what are their mechanisms. So we will continue it in next slides.